Hi, so this talk is about the Transformers.jl, models and framework in Julia. I'm Peter, the author of this package. In case you don't know what this is about, Transformers.jl is a pure Julia implementation of the transformer model built with Flux. And Transformer is a deep learning model that has an attention layer and other layers. There are some famous models built on top of Transformer, like BERT, GPT-3, DLE, and Imagine. You might already seen this kind of picture on the internet, and is built on top of Transformer model. In this talk, I will talk about the tokenizer design and how to define your own Transformer model, and also some progress on the Hugging Face integration. I only have 8 minutes, so I will scan through the new feature and design quickly. So let's start with the tokenizer. Transformers were originally made for the natural language processing, and tokenization is an important step for NLP. Because it is part of preprocessing, and what you need to do is highly dependent on the dataset and model you are working with. It's hard to know what information is needed without knowing the actual usage. So in the previous version, we only provide the core implementation you need as some standalone functions. Then you have to combine it in your own preprocessing function. In the newest version, we designed a tokenizer API that can simplify the process and still remain customizable, which look like this. A text encoder consists of 3 parts: a tokenizer, some config, and a processing pipeline. So the new design is based on text encode base.jl. In that package, we provide a set of API for defining customizable tokenizer, common preprocessing functions, and composable pipelines. Each line in the pipelines is a pipeline object. You can see what function is being applied on what arguments. And then you can replace some of it to form a new text encoder that have different preprocessing functions. After the tokenizers, let's talk about the transformer layer. A transformer layer consists of an attention layer, 2 normalization layer, a 2-layer dense chain, and wrapped in 2 residual blocks. Most parts are already available in Flux, so the only thing we need to implement is the attention layer. Therefore, I separate the implementation into another package named neural-attention-lib.jl. In this package, we provide several functions that can be used to define attention variants. We decouple the operations in the attention to make it possible to switch part of the operation. It is also general enough to work on data like pictures or videos. With this package, we can define attention variants like cursor attention, local attention, etc. Though currently they are not optimized for sparsity, so they will all use the same amount of memory. For example, this is a simple self-attention with 4 heads implemented with neural attention lib. The NHA is a flux layer that contains the required dense layer. Here, if you give different kind of mask like cultural mask, it will become a cultural attention. Our transformer model basically built on top of this library, so you don't really need a full transformer package to define your own transformer models. The last part is about the Hugging Face integration. Just in case you don't know what Hugging Face is, it's a company and also an AI community. They have a Hugging Face hub that have many pre-trained models and datasets. The Hugging Face transformers and datasets are 2 Python packages that get access to the file on the hub. What we are interested in is the Hugging Face transform package and the hub, because there are lots of people uploading their model to the hub. And the package contains many transformer implementations. To begin with, we have the Hugging Face API.jl, which is a pure Julia package that can interact with their hub. It can download files from the hub, manage the download files, and also query the hub to find the model you want. For example, if you want to find every model that is based on bird and have PyTorch implementation, and also have a specific file in that repo, we can use the list models with corresponding filters. Then with HF hub download, we can download a file from the hub. We can control whether to capture a result or not. Like GitHub, you can have private models on Hugging Face Hub. You will need to log in to access this file. We then use Hugging Face API in Transformers.jl. There are some requirements to use models from Hugging Face. First, you need to have a Julia implementation of that model, and the model weights need to be stored in PyTorch format. This tool might change if we have the ONX support. Then the last one is we need to have an implementation for the tokenizers. If all the requirements are met, you can use the HGF string to load the models. For example, loading a bird based on case tokenizer with the HGF string, or load the bird model. Here, like the Hugging Face transformers, you can also specify the task, so it will initialize the model accordingly. So in summary, we first talk about the new customizable and composable tokenizer design, and then we show how to define transformer variant with the neural attention lib. And last, we talk about what we currently have for the Hugging Face integration. That's it. Thanks for listening.